Okay, let's get something straight, right from the start. You've probably heard it a million times, or maybe just assumed it. Heavy things sink, light things float. You drop a rock in a pond, and splash, it's gone. You toss a leaf on the water, and it just chills on the surface. So, case closed, right? Heavy equals sink, light equals float. Well, I'm here today to tell you that your brain is playing a little trick on you. It's a super common idea, but it's not the whole story. The real secret is a little more clever than that. Imagine a tiny iron nail, the kind you'd use to hang a small picture frame. It feels pretty heavy for its size, right? Now imagine a giant block of polystyrene foam, the stuff used for packaging, that's as big as a microwave oven. If you pick them both up, which one would actually be heavier? The giant foam block, for sure. But if you threw both into a swimming pool? To crack this floating and sinking code, we need to get to know our two main characters: mass, volume. They sound like a superhero duo, and honestly, they kind of are. First up is mass. Mass is the measure of how much stuff is packed inside an object. Think of it as the total count of tiny atoms and molecules. We measure mass using a scale: grams, kilograms. A bowling ball has a lot of mass. A balloon, even if it's the same size, has very little mass. Next up is our second hero, volume. Volume is all about space. A tiny marble has a small volume. A giant inflatable unicorn has a massive volume. For simple shapes, measuring volume is super easy. Measure the length, measure the width, measure the height, multiply them together. 10x5x4, 200 cubic centimeters. But what about weirdly shaped things? Classic experiment, water displacement. Take a container with measurement markings and fill it with water. Note the starting level, 40 milliliters. Gently submerge the object. Water rises to 56 milliliter. The rise equals the object's volume. The object pushed that much water out of the way. All right, you've met mass and volume. Now it's time to introduce the mastermind, density. Density describes how much mass is crammed into a given volume. It's how tightly packed the stuff is inside an object. Density, mass, volume. That's it, a simple division. Use grams and cubic centimeters, and density is grams per cubic centimeter. This one number tells us a lot. Back to our examples, iron and polystyrene foam. Imagine a perfect iron cube, 1 centimeter on each side. Volume, chakra 1 cubic centimeter. If we put that iron cube on a scale, we'd find its mass is about 7.9 grams. 7.9 grams divided by 1 cubic centimeter equals 7.9 grams per cubic centimeter. If we weigh that, its mass is only about 0.05 grams. 0.05 grams divided by 1 cubic centimeter equals 0.05 grams per cubic centimeter. Look at those numbers. Iron is way denser than the polystyrene. The particles in iron are huddled together tightly. The particles in foam are spread way out with lots of air pockets. So now we have a rule for floating and sinking. Compare an object's density to the liquid it's in. For us, that liquid is usually water. Water has a very convenient density, almost exactly 1.0 grams per cubic centimeter. If an object's density is more than 1.0 grams per cubic centimeter, it will sink in water. If its density is less than 1.0 grams per cubic centimeter, it will float. Our iron cube sinks. The polystyrene cube floats. Mystery solved. Okay, time for the main event. We know that a solid block of iron or steel, with a density of around 7.9 grams per cubic centimeter, is way denser than water, which is 1 gram per cubic centimeter. So if you drop a steel bolt into the ocean, it sinks like a rock. No surprise there. But then, how on earth does a massive ship, a floating city made of millions of kilograms of that very same steel, stay on top of the water? Does it defy the laws of physics? Nope. It actually uses the laws of physics in a super clever way. The secret isn't in the steel itself, it's in the ship's shape. A ship isn't a solid block of steel. It's a carefully shaped steel shell. And what's inside that shell? Mostly, it's air. There are engine rooms, cargo holds, cabins for people, and hallways. All of these are just big pockets of air wrapped in a steel skin. Air is incredibly not dense, almost zero compared to water. By building a ship with this huge, hollow structure, engineers massively increase its total volume without adding nearly as much mass. They are essentially mixing the high density of steel with the super low density of a whole lot of air. This brings us to the idea of average density. We take the total mass of the entire ship and divide it by the total volume the ship takes up, including all that air inside its hull. Because there is so much low-density air inside, this clever trick brings the ship's average density way, way down. Engineers design it so that this average density is less than the density of water. And as we know, if your average density is less than water's, you float. So there you have it. We've cracked the code. It's not about being heavy, it's about being dense. Mass is the stuff. Volume is the space. Density is the magic number that tells us how packed that stuff is. And we learned that you can cheat density by adding a bunch of air to your design, which is exactly how those massive steel ships float on the ocean. Instead of joining the submarines at the bottom, you've basically just learned one of the most fundamental principles in all of engineering and physics. Pretty cool, huh? The world is full of these little science tricks that seem like magic until you understand the simple rules behind them. To quickly recap the big ideas, mass is how much stuff is in an object, and volume is how much space it takes up. Density is simply the mass divided by the volume. And the golden rule for our planet's most common liquid, water, is that anything with a density greater than 1 gram per cubic centimeter will sink, and anything with a density less than 1 gram per cubic centimeter will float. It's that simple. By shaping steel into a hollow hull, a ship traps a huge volume of air, making its average density less than water, allowing it to float. Now, it's your turn to put this knowledge to the test. Here is your final mission, should you choose to accept it. Go find a piece of aluminum foil. First, crumple it up into a tight, solid little ball. Aluminum is denser than water, about 2.7 grams per cubic centimeter. So what do you think will happen when you drop it in a sink or bathtub full of water? Give it a try.
I'm going to stack 3 liquids and make a chemistry parfait. Syrup on the bottom, water in the middle, oil on top. If I pour slowly down a spoon, they settle into clean layers. Show first, explain after. That happens because of density, how much mass fits into a certain volume. More dense sinks, less dense floats. Crude oil is less dense than water. When a ship leaks, the oil spreads as a slick on top of the ocean. Those black waves washing onto beaches are a reminder that density decides where that oil goes. Now what about gases? Gases are way less dense than liquids because their particles are farther apart. That's why raindrops fall. Liquid water is denser than the air around it. Gravity pulls everything down, but the denser thing ends up below. Grab a fizzy drink. The bubbles are carbon dioxide gas, around 0.002 grams per cubic centimeter. The liquid is close to 1.0, basically water. The tiny CO2 pockets rise, carrying bubbles to the top, and popping. Not all gases are equal. Helium is one of the least dense gases you can easily buy. Fill a balloon and it floats because the balloon plus helium weighs less than the same volume of air. Hydrogen is even lighter, but it's reactive. Mix it with air and it can explode. That's why helium wins the party. Gases are squishy. Compress a gas and you cram the same number of particles into a smaller volume. Density goes up. Let it expand. Density goes down. Heat makes gases expand, so hot air is less dense than cold air. That's the secret of a hot air balloon. Warm the inside, reduce its density, and it rises through cooler, denser air like oil on water. So the pattern holds. Stack liquids, float balloons, fizz drinks, even steer giant balloons. Density quietly calls the shots. Once you see it, you can't unsee it. A hot air balloon floats in air because the density of air decreases as its temperature increases.